Scientists finally did it, or at least they might have. For decades, humanity has stared at Mars wondering if it was ever alive. And now, the latest evidence suggests maybe it was. To understand what this discovery means, not just for science, but for you, we'll have to travel far back in time. But not just 1 billion years. Let's go all the way to the birth of a planet that once had oceans, rain, and maybe life itself. About 4.5 billion years ago, in a swirling cloud of cosmic dust, Mars began to form. It was the pre-Noachian period, when the solar system was violent and chaotic. Chunks of rocks smashed together, melting into a red, molten sphere. And slowly, this chaos shaped the planet we now call Mars. With a dense core, a rocky crust, and a sky filled with ash and vapor. Back then, the young planet wasn't a frozen desert. It was hot, dense, and wet. Scientists believe an ocean once covered nearly a third of its surface. Picture shimmering blue waters reflecting a warm, orange sun. It wasn't Earth, but it was close enough. Over time, the planet cooled. Volcanoes spewed gases into the sky, building a thick atmosphere that trapped heat. Clouds formed, rains fell, and rivers carved deep valleys. It was the first and only age where Mars may have looked like home. Fast forward to around 4 billion years ago, the Noachian period. The planet was alive with energy. Asteroids pounded its surface. Volcanoes erupted across its crust. And a global greenhouse effect kept it warm. Mars had clouds, rain, likely acid rain, and valleys that shimmered with running water. That acidic rain dissolved minerals from the rocks, filling rivers and lakes with nutrients. A perfect recipe for microbial life. If life could begin anywhere, this was the moment. Deep within Martian lakes, tiny microbes may have stirred for the first time, drawing energy from sunlight or chemicals beneath volcanic vents. But then something changed. Between 4.1 and 3.7 billion years ago, Mars began to lose its heart. Its magnetic field, that invisible shield protecting it from solar radiation, started to fade. Without it, the planet was defenseless. The sun's charged particles, the solar wind, tore through Mars's atmosphere, atom by atom. Oceans began to vanish. Temperatures plunged. And with every passing century, Mars inched closer to death. Yet, for a while, it fought back. Volcanoes like Olympus Mons, the largest in our solar system, continued to erupt, releasing greenhouse gases that kept small patches warm. For a few million years more, Mars clung to habitability. Billions of years later, we're still searching for proof that life once existed there. And some of the best evidence lies in an ancient Martian crater, Jezero Crater. That's where NASA's Perseverance rover landed in 2021, exploring what was once a vast lake and river delta. Among the dusty plains of a dried-up river, Neretva Vallis, the rover found sedimentary rocks, rich in clay and iron. These rocks, known as mudstones, can preserve microscopic fossils for billions of years. Inside them, Perseverance detected traces of two minerals, vivianite and gragite. On Earth, these minerals are often created by microbial life. They appear as faint, colorful leopard spots. And to scientists, they could be Mars's way of whispering, "I was once alive." Dr. Ed Clutis recorded, quote, "We haven't found life on Mars. We've found possible remains of life, where we find this same mix of minerals and organics on Earth. It's almost always linked to biology. It's not proof, not yet, but it's the closest we've ever come." A sample return mission, planned for 2031, could finally tell us if those rocks hold Martian fossils. If they do, it would mean life didn't just arise on Earth. It began twice, in the same solar system. Let's jump forward again, to about 2.9 billion years ago. Mars entered the Amazonian period, the longest and final chapter of its history. Its magnetic field was gone. The air thinned to almost nothing, and the once blue world froze beneath a red haze. Surface temperatures dropped to minus 60 degrees Celsius, minus 76 degrees Fahrenheit. Water could no longer exist on the surface. It boiled away or froze instantly. Only deep underground, hidden in salty aquifers or geothermal pockets, could any remnant of life survive. Mars's volcanoes tried to keep it alive. Every time Olympus Mons erupted, it released carbon dioxide and heat, briefly warming the air. A dying planet's last, desperate breath. But even that couldn't save it. By 1 billion years ago, the Mars you'd live on looked almost identical to the Mars we see today. Dry, silent, and endlessly red. So let's imagine you, standing on Mars 1 billion years ago. The ground beneath your boots. Iron-rich dust that stains everything it touches. The air, thin, suffocating, made almost entirely of carbon dioxide. A faint sun hangs in the copper sky. No oceans, no rain, only endless desert and frozen dunes. Far to the west, Olympus Mons towers 22 kilometers high, 3 times taller than Mount Everest, and wider than the state of Arizona. Even from hundreds of kilometers away, you could see its shadow stretch across the horizon. Sometimes it rumbles. Lava seeps across the plains, briefly warming the planet before the cold returns. In those short, fiery moments, maybe, just maybe, life underground stirs awake. Billions of years ago, rocks from Mars were blasted into space, and some landed here on Earth. We've found over 400 Martian meteorites scattered across our planet. If microbes once lived on Mars, then pieces of that ancient life could have traveled here, seeding our own beginnings. Maybe that's why, when we look at Mars, it feels strangely familiar. Because in a way, we might all be Martian. Mars is more than a dead planet. It's a mirror of what we were, and what we could become. And as we prepare to return, to step once more onto that red soil, perhaps we're not exploring a new world at all. Maybe we're just going home. What if you lived on Mars 1 billion years ago? The truth about ancient life. If life began on 2 worlds, what other secrets are still waiting out there? Don't stop here. The next mystery might change everything you thought you knew. Hit the subscribe button to watch next mystery before the truth gets buried forever.